Things are coming along quite nice in our little project, but we have a few issues and rough edges, like our moonwalking bug. And today we're going to do a little bit of cleanup work with some issues in our player. Hi, my name is Michael, and welcome to my 2D action and adventure RPG tutorial series. We are learning how to build a top-down 2D game that features action, adventure, and RPG mechanics all in Godot 4 using GDScript. So I received a comment or a question from @TheDarkerSan who asked, why not control the hurt box with the attack animations? More control and less complications. I would make the collision imitate the shape and position of the sword, for example. And actually that's a great question, and in previous projects I've done this, and I did some reflection on how I built this one, and there is one minor issue with our attack that I think this could help address. So I'm going to do a partial change to this to kind of go along with this comment, but I also want to maybe defend some of the reasoning if that's needed. Defend's a strong term, I think, but justify a little bit further some of the reasons why I've done more through code than through the animator. Let's look at the project with the debug on, and you can see that the attack circle, when I'm facing up, it doesn't seem to reach the extents of the attack, and when I'm facing down, it seems to extend far past it. And then on the side, it seems okay for the most part. But positioning this with the animator will make it a lot easier to avoid those kinds of issues. And as the commenter suggested, you could make the attack box match or follow the direction and rotation of the weapon. I don't want to take it to that extent because I think just a general circle is sufficient for what I'm planning. And animating the sword in that fashion, or the hurt box in that fashion, could introduce some complications later on. So I'm going to leave that up to you as an exercise to do on your own if you decide you want to for your project. But let's go ahead and make some changes to our current project and just see how this might work. So I'm going to make sure I've got my player scene open. We're going to move some things around. So first of all, let's take our hurt box and let's move it to be a child of the sprite 2D. I'm doing this for a very specific reason, and that's because our animations with our sprite are only designed with up, down, and side, and then we flip the sprite on the negative. We flip the scale with a -1, if you recall, on the side to make it face left as opposed to right. So in order for our hurt box animations to work with that, we're going to make the hurt box a child of the sprite 2D, so when it gets that -1 scale applied to face left, the hurt box will get flipped and scaled appropriately as well. And then because we've done this, I want to do just a couple things with the hurt box. I'm going to give it a more unique name. Call it attack hurt box. I don't think we'll add another hurt box, but just in case, I want to do that. And then I'm going to right click on it and choose this option to access a unique name. And that gives us this little % symbol on it. And then when we open our attack state script in our state machine, we need to correct one thing here. You notice our hurt box was looking for a reference to this hurt box in its previous location. But now that we've changed this, let me just go ahead and delete this, the second part of this line that identifies where the hurt box is. Now if we control drag this in, oops, I don't want to control drag, just a regular drag. You can see it says % attack hurt box. Now it doesn't care where the location is because within this scene, we've assigned it this unique name, and so it knows it's the only node with that name. You don't have to do this, and in fact, I don't normally do this, but it's pretty handy when you know that you're going to be maybe moving a node around the scene tree as you're working. Yeah, this could be an important thing to do. So here we go. We've got our hurt box changed. It should still function. I'm not going to actually change anything else in code. I'm going to leave the hurt box monitoring setting here in code, and that's because if we're playing our game, and let's say I attack and I take damage midway through the attack, I want the hurt box to still get disabled when we leave the attack state. And if we leave disabling and enabling of the hurt box up to our animator, it is possible to leave an animation before we get to that keyframe at the end that would turn it back off. And so I don't want to do that because that will introduce bugs, almost certainly. I also foresee having like a dodge roll mechanic that could have the ability to interrupt an attack animation mid-attack. And that's another situation in which we still want our hurt box monitoring to be set to false by the script. It's just a lot more safe that way. But let's go ahead and go back to 2D and to our player. And we're just going to set up our hurt box with our animations. So let's go ahead and select our animation player, and let's start with the attack down animation. All we're going to do here, zoom in on this timeline just a tiny bit, is we're just going to add a simple position keyframe to our attack hurt box. Okay, so you could select it while we have the animation open, and then under transform a position, we could click the key and just go ahead and say create. Okay, so we're going to change the position here. And actually, what I want to do, and you can go along and do this with me, or you can just take the numbers as I give them in a moment. I'm gonna get the attack down slash animation, and I'm gonna play it out here somewhere in the middle so that that slash is fully visible. Then I'm gonna come back to my hurt box, and I need to select this other animation player actually. So get our root animation player, make sure we're on the attack down, grab our hurt box, and let's just move this to where it feels about right. And I'm gonna say maybe right here at 17 pixels down. Okay, I mean, you could go 18, you could go 19, it's up to you. But I'm gonna just stick with 17. So let's select this keyframe over here, the first keyframe, and we'll change the Y value to match that, 17. Okay, there we go. And we're not gonna animate this. You could if you wanted to. I mean, you could start with, let's insert a keyframe here. You could start with the value at 10 or something like that, and then have it animate. Oops, I guess I didn't add a keyframe. You could add a keyframe here. Oh, there we go. Now it's set to 10 and 17, and have that circle animate. You could get really complicated, and if you had a shape that matched the shape of your sword, right, you could come back here and start it over here and grab this position, bing, okay, and then have it animate this way. Or, I mean, you could get really complicated, right, and have it match the full arc of the sword. But again, for the sakes of this tutorial and for what I'm going to do, I don't want to mess with that. It does add complication that I don't think brings any extra great value. You know, that's up to you and your project. You might be trying to do something very specific where I'm making, you know, a basic top-down attack here. Okay, so I'm just going to leave that there at 17. Now let's go ahead and copy this hurtbox position track. And I'm only going to update this in our attack animations. So let's go to attack side, paste it. Let's go to attack up and paste it. And then let's modify the values here. For the attack up, this is going to be probably just a -17. Let's check that out and see how it looks. And actually, just for verification, I'm going to get my sword attack effect and change that to attack up. There we go. Yeah, that's pretty good. That kind of matches the positioning of the attack down. While we're here, let's go ahead and change this to attack side. Okay, let's get that out there. Go back to our player, attack side. So now this one, right, we're gonna want to take our hurt box and put it out here somewhere, 17 or 18 out to the side. You'll notice the difference of how we're doing it here is we're just making this hurt box match visually where the sword is maybe doing its damage, as opposed to how I was doing it before, which was trying to be physically correct, which doesn't always work in a top-down 2D pixel art game. Okay, so there we go. We've got that. I'm actually just going to set this to 17. Then they're all 17 pixels offset from the center. And oh, I need to, yep, there we go. Okay, so there's our, oh, I didn't save it. That's on the wrong axis. 17 and 0. I'm just going to type it in manually. I forgot to hit the key button when we were moving it. Okay, so there we go. We've got our different attack animations. So now when we play the game, and I'm going to leave debug on so you can see this, we no longer have the attack box moving as our player moves, but as soon as we attack, it's going to snap to the correct position. And you see it is flipping when I go left or right, because remember, we're scaling the parent, which is the sprite 2D. So it's moving with it there, but then when we look up or down, right, it's only going to update truly when we actually do the attack. But it's not important because it's not going to do any damage when it's not attacking, because remember, we're controlling the monitorable status of this hurt box from within our attack state code. Okay, there we go. That's good. I'm going to close this. I'm gonna go here to the debug and just turn off my visible collision shapes. Now that we've updated how the hurt box on our attack animation is gonna work, I want to update our plant as well. So if you look in the props, the plant that we created in our last video, we want to make a change to how this collision shape is set up for the hitbox here. Now, real quick, before I resize this, you'll notice as I resize it, we've got something goofy happening, because when we created the collision shape for our static body, we just duplicated this one. And so the shape that these two collision shapes are referencing right in here is actually the same shape. So we can just select the collision shape on our hitbox, click this little arrow drop down and click make unique. And then just so that it's obvious that it's different, I want to change the debug color to some like a yellow color for this hitbox. Okay, so now if I resize the hitbox shape, you can see that the collision shape of the static body is not being updated. And by holding Alt, you can symmetrically change things, resize or move these nodes. Okay, so there we've updated the collision shape on that. Let's give this a quick test. So now I should be able to chop down a plant, even if I hit just the top of it. Wink. There we go. Okay, looking good. And now I want to look at another comment that I received actually on the previous video as well. And this from It's Not Hero Hanix, who commented, there seems to be a problem with the player animation when going diagonally. The player sometimes moonwalks if you press two keys at the same time, and I think it has to do with the set direction function in the player script, but I can't figure out a way to fix it without forcing the player to face one direction. And he also proposed a little change that seemed to work for him. So It's Not Hero Hanix. If that works for you, that's great. And that's what everybody should be doing, is trying to see what they can do to make this code and this example work for them. But I've also given this some thought. And if you recall in a previous video, we did see this moonwalk animation happening where you're, walking left, but you're facing right or something like that. And that will cause a problem because that means our direction's not updating properly. And the player could end up attacking facing the wrong direction and die because they got hit when they should have been facing the other way. Anyways, you get the point, right? So let's go ahead and address this. And all of the changes that we need to do to fix this are going to be done from within our player script. So let's go ahead and open the player script, and we're going to change this set direction function. This logic here, where if the direction y equals 0 and x equals 0, is a little bit flawed. The rest of the code down below seems fine. I don't think we need to change that. We just need to address this right here. And I'm going to go ahead and just delete that whole section of code out. And there's one other thing that I want to do here. I noticed this as I was refactoring this code. We're setting a variable here before we check if we even need to run the function. We really shouldn't do that, right? Because if we end up, if this condition is true or the vector2 is 0 and then we return, we don't do anything else, then it's really pointless to put this little variable into memory. So I'm gonna go ahead and delete that line as well. Okay, hey look, our code's shorter, nice. Of course, it's not gonna work, we've got a few issues here. What we're gonna wanna do is we're going to define a new variable. Now, I spend a lot of time playing with this and trying to come up with a surefire way to keep this bug free, or at least as bug free as I knew how. And I think there are some simple ways we could do it, but I came across a pretty ingenious solution, and I found it used in multiple places in one form or another. We're going to set a new variable called direction ID, and it's going to be an integer, right? So it's of type int, and it's going to equal this int, and we're going to create a new integer to pass in here. Some really smart people found that, yeah, you could just find the angle that this is and use that to get yourself a cardinal direction. And there's a certain way that they do it. And actually, before we can fully do this, we want to create a constant variable for our directions. So we're going to have a new constant here. And we'll just call this dir_4. Okay, and this is going to be an array. And these are our 4 cardinal directions that we're working with here. So we can just go ahead and lay those out. And actually the order that we do these is important because of the way the code works. So start with a vector2 right, then vector2 down, then left, and lastly vector2 up. Okay, oops. Okay, there we go. So we've got this new constant. A constant is a variable that doesn't and cannot be changed. So these values are never going to get changed. We're just using them as a reference, essentially. Okay, so let's go back down to our code here where we're updating our set direction function. Now we're going to do a couple things. We're gonna round our direction ID. Remember, the direction ID is an integer, so we need to round it to the nearest integer, because what we're going to get out of this next little bit of code is a float, a number with decimals, and we don't want decimals. And then we're going to, inside of this round function, make another set of parentheses. I give an extra space here because it helps me a little bit when reading it. It's up to you guys if you want to do that. So we're going to grab our cardinal direction. Wow, why did I type carding? Cardinal direction. Okay, you don't need to put this part in parentheses, but we will later, and I'll show you why. And we're going to get the angle of that cardinal direction. So remember, a cardinal direction is a vector 2, and a vector 2 can calculate an angle, right? Which direction it's pointing, like up would be pointing up, and, you know, left, right. And then we need to divide this by tau, and then multiply this by the size of our array, or direction for array. So when we take this angle and divide it by tau, we're going to get a number from 0 to 1. Okay, and then we're going to multiply it by the size. So essentially, by the time we do this, we're going to get an angle, and we're converting it down. All this really says is we're going to take an angle that could be anywhere between like 0 and 360, and we're going to make sure that it only relates to one of these directions. Okay, right? One of these directions here. We don't want to get any other direction in between. Then all we have to really do is, remember I removed setting our new direction. We'll go ahead and set it at this point. So our new direction is going to equal, it's going to equal the direction 4 at this position. Okay, so let me try and explain this one more time. We created a direction ID which is an integer. It's going to be a number between 0 and 3, because that's what this code's going to give us. It's going to say, get an angle, convert it from 360-degree angle to a 0 to 1 number, and then multiply it by the size of the array, right, which is 4. So that means the possible values are, or technically up to 3. And then we're just going to set the new direction to that, whichever item it is, whichever index that is, because this is an array, and how arrays work is if we were to specify 0 in the array and look at our array, that's going to be right. If we were to put a 1, in here, then it's going to get item with an index of 1. So arrays begin with an index of 0. 0, 1, 2, and 3. Okay, so here we go. Let's just put our direction ID back in there. So now we're going to just determine which one of those to grab based off of this angle. Boy, I hope that makes sense. This is a little bit weird and confusing of a line of code, but if you just want to copy it as is and paste it in without understanding it, that's acceptable. You've got time to learn. Okay, so now that we've done that, I think our code should be working. And if we run the project, oops. Something's not working, huh? What did we do wrong here? Okay, took me a minute to realize what I did wrong here. And that's that we don't want to pass in the cardinal direction, right? Because that was the direction we were already facing. We want to actually take our regular direction and use that to get our angle. There we go. Now it's working. Now there is one thing here, and that's that, see, if I'm holding up and pushing right, then he keeps looking up, right? But then if I push left, then he faces left. And I kind of want that to be consistent. I want the key that was first pressed by the player to be honored. So if I'm, like here, I'm pushing left and I'm pushing up and down and it's still looking left. But if I push right, push up and down, then he looks up and down. Now you can keep this or do what you want with it, but I came up with a solution on my own that does what I want it to do anyways. And so what I did is, and this is the reason why I got cardinal direction mixed up in here, because I do want to work with the cardinal direction. So I'm going to take our direction, but I'm going to bias our direction towards our current cardinal direction. Okay, cardinal direction. I don't want the full cardinal direction though. I just want a little bit of it. So I'm going to multiply it by 0.1. What this is going to do is it's going to give me a direction, but it's going to just skew it a little bit towards the cardinal direction. So that means that if I'm already facing up and then my new direction is like diagonal up and right, it's going to favor looking up because that's the direction I was already facing. Does that make sense? If I was facing to the right and then I continue to hold right and press down, then again, the direction is going to be a down right direction, but it's going to bias just a little bit towards right. So the ultimate end result of that means that I'm always going to be facing in the direction that I was previously facing. So now if I'm holding up or down and hit left and right, I don't get that toggling between animations. Same with it going right and hitting up and down and left and up and down. But as soon as I, let go and go a single direction, there we go. So no more moonwalking with this code. Hopefully it makes a little bit of sense. Let's go ahead and get rid of our print. I added that in there when I was debugging while I paused my recording. So yeah, that's it. That's all we had to do to fix that direction bug. It's actually one nice simple line of code, and if you don't understand this and just kind of ignore it a little bit, then it works. But if you came up with your own solution and you like how it works, then that's great, and keep doing what you're doing. So that's all we're going to do for this video. And next time we're going to work on getting our player camera to be stuck or to not extend past the edges of our tile map. So look forward to seeing you next time.